Hello everyone and welcome. This is an example lesson of what we could do as part of an online engineering recruitment. It's a little bit different because we'll probably have a different background, but give a pretty good idea of what we can do. So many of the things that we like to do in engineering is we like to solve problems. So instead of sitting around and talking about all the different ways that things aren't going the way we expect and the way the universe doesn't really behave in the way that we would like it to, all the different inconsistencies, all the different problems, all the things that are wrong in the universe, it's real easy to sit around and talk about why they're wrong. Instead, what we want to do as engineers is start thinking about how do we actually solve problems. So one of the things that's very topically relevant today that I thought of as a good example is how we can start from something without having to lay out any initial cost to the potential students that are being recruited through this method. What we can do is we can use something like Tinkercad. Now this is owned by Autodesk, and so we're going to walk through a little bit about how to use this. But first we want to think about what's a problem that's topically relevant for today. So one of the big ones is this talk about coronavirus and all the things, right? So one of the things that we want to be able to do is something that we can design, something that we can use our engineering know-how in order to solve an actual problem. One of the things that I've seen suggested recently is this idea that we can use 3D printing technology and some of our CAD design. So we can even do some of the CAD design here in this software, as you'll see in just a few minutes, where we can build face masks, and we can build them in such a way that we can export 3D printable files, and this will actually work really, really well. We won't go all the way into the detail about the 3D printing and things and all of the various considerations for print orientations and things yet, but the point is we'll be able to work on a project, come up with an idea, personalize it a little bit, and then create a customized version of a mount for a face shield that will go as basically a headband. So one of the things we need then is we need to know something about the human head. So I pulled up an image from the Wikimedia Commons that actually gives us some pretty good information, and because of the way that Tinkercad is set up, I'm going to be using the metrics side. I know, really scary, but that's okay. Metrics won't hurt you, actually. So there is no such thing as freedom units. That's not actually a term. They're actually called imperial units, probably because they're used by the Empire and they're Darth Vader's favorite. I like Darth Vader, so I like using those units, but for most things when we're actually designing, building, and testing, a lot of times the metric system is actually very helpful. So let's go ahead and use that. Now, one way that you can kind of confirm where your head size is you can find something like a piece of string lying around. You can try and wrap it around your head. If you have something that's unusually large, as apparently my head is, I needed most of this 30-foot tape measure to be able to figure out, once I measured the string, exactly how big my head is. Now, I'd been told by others that my head is pretty large, so I guess maybe they were telling the truth, although I don't think that's actually what they meant. So joke's still on them, or is it on me? Nobody really knows. Anyway, the point is we have some interesting information here. So one of the key metrics that we want to pay attention to is both value 6 here, and so we see the average is somewhere around 14.5 for men, 13.3 centimeters is this scale, and then the approximate length of the head is going to be more like this value 13 here. So this is the head length, strangely named, right? 19.7 and 18.7 for women. These are all the averages, so somewhere around the 50th percentile. This is technically the median, but we'll get a reasonable estimation there. So we know that we need a couple of those key dimensions. So we have our 14.5 or 145 millimeters, and for 13 we have 197 millimeters. So let's go ahead and jump over to Tinkercad. This is real simple. It's something you can sign up with as an email address. You can link your Google email, whatever's easiest for you. And we're going to start in the drawings. There's lots of really cool things that you guys can do. And one of the reasons I really, really like using this tool is there's lots of options when we go to make drawings. So you want to create a new design. And I've already got one that's just a blank sheet. So I'm going to go ahead and hit Tinker this. And what we're going to see is a couple things And we want to start out by seeing, well, we have a work plane here. So let's talk about a couple of the different commands. They've made things really, really easy, both if you have a mouse and a trackpad. Now, if you're going to do engineering, you're going to need a mouse because it's going to make all this CAD work and 3D drawing and 3D printing and all this manipulation really easy. You'll kind of see why in this demo, because I'm going to need to be able to kind of go back and forth between different views. So I'll move my camera a little bit out of the way here in order to, so that you can see what's happening with some of this, or maybe I'll change the window size ever so slightly. So what we're going to see is we're going to see a couple key factors. I want you guys to be able to see this control up here at the top. So this is one of our ways to control the view. We can click the top view, we can click the corner views for different things. So you can always go back and forth here and rotate if you're just working on a trackpad. Totally fine. You can also click and hold, if you're using a mouse, the scroll wheel to move the work plane around. It's very helpful, especially up and down, so vertical movements. If you hold and right click in this environment, you can rotate the work plane. I use this feature and the zoom a lot when I'm drawing because it's just helpful for me to see different things, see it from the underside, see it from the top side, make sure that I've got the clearances I need. Okay, so we need some kind of a shape that's going to make a headband. Well, there are a couple options here in the basic shapes. They have a lot of other options for how these are run. So some of the basic shapes in this case that we're going to use are going to be something like, you can use either this torus or toroid shape, you can use a ring, or you can use a tube. So a tube is going to be one of the really just the simplest designs. So we click this, we set it down into our workspace, and what we're going to do is we're going to move this so that we can see a little bit more easily on the top, because we have dimensions shown when we don't have when we're clicking one of these corners or hovering over one of these corners, but we need to know a little more information in order to get it the size that we want, because you can click one of these and get the dimensions to show up, but life becomes a little easier if you just quickly drop a ruler from kind of this top right corner. You drop a ruler into this, and now when you click the part in general, you'll get all of this data showing up. Now, my particular head, seeing as how I needed all 30 feet of this to figure out how big it was, is going to be a little larger than this average. So this particular headband won't actually fit me, but we'll kind of target the average so that you guys can see an example of how we really do this. So one of the things that we want to do is we want to set up our overall length. And so from our dimensions here, using the values, 13 is our length, so this is about, let's do about 197 millimeters. So this is 197, enter, and we're going to also change our width, so our overall width for this based on our value 6 here is going to be about 14 and a half, so 145 millimeters. And what we see here is a shape. Well, it looks like the average person does actually in fact fit on the work surface, so that's kind of neat. A 10 millimeter height is reasonable. We may want to trim that down just a little bit because we want to think about if you're going to be wearing this all day long in a regular environment, you want to keep it fairly narrow. So we probably actually want this to be closer to something like 6 millimeters. So we just type 6. And then we want to think about, for this, you can tell it how many sides and some of the other things. The wall thickness can be much, much larger or much, much smaller. So we don't want this to be really sort of an infinitely thin band. But the reason why we want to use one of these tubes instead of something like the ring is we have a lot more dimensional control overall. So that helps us get a lot more useful information. Now, one of the things that we can do is we can take this, and if you think about the approximate dimensions of someone's head, the person that is, you know, at least about 6 feet away from you, right, is probably not going to have the same head shape as you will. So instead, one of the things that we want to think about is, how do we make this modular? Well, one of the easiest ways to do this is actually to add another shape, and that's going to be up here toward the top. We have these kind of zebra striped pieces. So some of the things that we want to think about is if we take a headband, if we want to make it applicable for lots and lots of people, what we want to do is make this a little bit wider and then bring this up. So we want to try and keep it centered, roughly in line with the center line of our whole piece here. So this is roughly centered, and what this will do, depending on how we have this positioned, is this will allow us to create what's called a hole in the piece we're working with. So we're going to set our dimensions, and we want to make sure that it still wraps around the back of the head but doesn't go all the way around to the very, very back, so that we can accommodate people like me who have gigantic melons. So one of the things that we can do is we can set the height of this kind of carefully, and we'll take off about 28 millimeters of the length here. So when we now use the left click, which allows us to click and drag to select, just like in a lot of software types, so it should be a very familiar thing. If you combine those, or group them is what this is called, it'll highlight them, and then we can see that what we've done is we've just paired a hole and a solid object, and now what we've got is we have a headband that's going to be flexible just like glasses are, right? So you have a shape and a geometry that allows for comfort and flexibility for all-day use and wear. So we're not inventing something new, we're just doing something that happens to be comfortable. Now the other part of designing this as a face shield means that we need to have this do something. We need to be able to hold onto a piece of plastic. So there's a way to use something like, even I've seen some proposals to use some transparency films. So kind of a thick paper-sized sheet of plastic that's clear and fairly durable. And something like that, if you run it through like a 3-hole punch, I've seen some variations of this kind of a design. So this is not something that's a brand new design to me. This is something that I've seen some examples of. So I'm going to turn our part around here. So one of the first things you'll need to do is somewhere toward the center line, you're going to need some sort of a piece. Now you can attach by the same method that we did by pairing a hole in a solid. If you pair two solids and group them together, you make a fused single solid piece of material. And by the time we're done, we'll be able to come up here to our export, and we'll be able to do all sorts of things and export it, including as file types like an STL, where we'll be able to actually load that onto a 3D printer. For some of the other kinds of designs, if you wanted to lay out a pattern for something like a face shield, that's an example of where we could output a laser cutting profile in an SVG. Now I haven't used a lot of laser cutters for my particular examples, but they also allow you to send them directly to a number of different prints. You could even have some of the 3D printing services do that. So lots and lots and lots of options for ways that you can use this kind of a print, even if you don't have access to a 3D printer. But you would if you come to GCU to become an engineer. So things to consider. So now what I can do is I can left click and drag this, and I can bring it into interference with the material right here. So what I can now do is I can shrink this down, because these don't need to be very wide blocks. They just need to be something that allow us to attach a couple of pieces. And now we can change our view again. We can decrease this. Here we go. So now we're roughly at the same height as everything else. And we don't need this to be we don't need this to be very, very thick. We only need this to be about, instead of 4 millimeters, we only need this to be really about 1.5 millimeters maybe or so, just to space it off of the band slightly. And we can even make this a little bit smaller, because what we want to do is we want to create kind of a I'm going to create kind of a pocket for this. So height, I'm going to bring this down to about a width of something about 4 millimeters is probably about right. And then I'm going to drop this height just a little bit, because what we're trying to do is we're trying to create a step that our part will sit on. If you want to get really fancy, instead of using a square in this particular location, you could actually use something like a cylinder, since we might be pairing this with a 3-hole punch, and that might be a little bit better idea. So we're going to take this and we're going to use this rotate feature to bring it 90 degrees. And we're going to say, okay, we're going to squish this down, drop this back a bit, and we want to line this up. So we're going to need something like, for our process, we're going to need something like about 4 millimeters or so and 4 millimeters. So a 4 millimeter round might be closer to about 3 millimeters, but that's going to be pretty close to a 3-hole punch size. These are all things that you can measure if you happen to have 3-hole punch and some paper handy. I don't happen to have any here at my desk. So then a couple millimeters of distance there, and we can then create our piece. Something simple like a triangle should allow us to pretty easily get that transparency film over our piece without having too much difficulty. We're going to use our rotate again, and we're going to change our overall height. So I'm going to make this a little bit smaller. So it's still going to be something like 6 millimeters high. We need to bring this down so that it's in line with the rest of our parts. To move pieces in the vertical axis, we're going to use this top arrow for any geometries that we're working with in Tinkercad. So we bring this down so that it's at the same plane, and we move this back. So we'll need to change a couple of our dimensions still, making this a fair bit smaller. Alright, let's see how close we are now. There we go. So we can see a little bit better now. We will have good fusion of material, but we need to keep this as close to the same width as possible. Bonus points if you know why that's important. That's important because as we're creating these parts, what we can do is make sure that by being about the same diameter, what should happen is as this prints, we'll make a couple more of these, a couple more copies of these. Now that we have them at about the right size, you can slip the transparency right over this top piece, and what that'll do is allow you to secure this, and it should hold very easily without being disrupted. So you should be able to move around freely and not have any restrictions on your head. So you might also have to deal with a rogue bicycle gang or some other crazy thing, because it is, after all, a new and interesting world that we live in. So we can copy this, and we can make a couple pastes. So we can bring this around to one side and around to the other side, and you'll have to get a measurement for about how far apart these pieces need to be. But we've got a couple of our pieces. We also need to copy our little cylindrical piece, so I'll bring this back down to a reasonable size, about 2 millimeters. I'm going to zoom back in a little bit to make this a little easier to manipulate. Here we go. So now I don't need to rotate in this axis, but I do need to rotate in this axis so that things are even. So something just about like this. I'm going to grab this other part and I'm going to match its rotation so that it's about the same. Grab it and connect it just like this. So we're going to check for any interference issues. This part looks like it's actually going to fuse pretty well. One of the ways that we can do that is we can select something like this headband, make it a hole, and what that allows us to do is kind of look from a top view to see if we're going to have good fusion of material, and we're going to be pretty good. But on this part, we just want to make sure that we've got just a little more material fusion. So we might want to move this actually right about there. I think will be okay. So you can change the snap grid size. That's what I'm fighting right now, instead of from 1mm to 0.1mm, and that'll allow you pretty free range. That'll get a little better resolution like I'm looking for. Okay, so this now allows us to get pretty good fusion of the materials. And if we also visualize this as a whole, you'll see a pretty good contact, but not as good as we would like. So we want to see a little dark area at the interference of all of those pieces. So we need to do just a slight bit of rotation on this part, like a degree or so, and then push it back just ever so slightly. There we go. So now you can see how most of this face is now dark in color. What that means is we're going to have really good material fusion. So now we can put this back together as a solid and put this one as a solid. We're going to do the same thing over here. So we're going to rotate so that we're working at about the same spot. And this guy is going to be, that should still be 4. So we're going to need to make a little bit of a rotation. We're also going to need another one of our circles. So we're going to grab this and we're going to copy it. And we may have to move it carefully. Sometimes you're going to have to make it a different size and then rotate it after the fact. We're going to rotate this to fit what should be. Let's take a look at the top. So this is why it's really important to be able to change some of these view angles so frequently, is to be able to measure just how much we're going to be moving apart. So in this case I need maybe about 10 degrees of movement and rotation. Something like this. And if I visualize this shape as a whole and I move down in the view, so I'm not quite interacting, there we go. So there I've got just a little bit of interference in the geometry, and I can check this one and see, looks like we're almost there. Yeah, looks like we're pretty close actually. So this is going to still achieve good fusion of the materials. So now what I can do is I can zoom back out again. I can say we have our piece, we have all of our sections together. We're going to make sure they're all selected as solid. We're going to select purple because we're talking GCU, right? And then we can put these all together in a group and make one solid material. So now we have a printable file that we can send out, and we can, after we export this as an STL, we can now solve some of the problems by using our ingenuity and engineering prowess. So there's a lot of cool and interesting ways that you can solve problems, and this is one of the examples. So I want you guys to work on this, and then I'll kind of chime in and answer questions as we go along. Thanks, and remember, GCU is where you're going to learn to actually do the things instead of just sit around and complain about them. So, important lessons. Thanks.